Hello, YouTubers. We meet again on another installment of Newton's Laws. I hope that we're going to have fun together once again. And today, as I tackle forces on an inclined plane, if you haven't subscribed already, please do so. And please tell all your friends, tell all your grandmother, anyone. I'm trying to make it a point that anyone and everyone can learn physics. Now, I think this will be the final installment of Newton's laws, and then we're going to move to the next topic. But what I will do is that I will tackle this topic when I do revision on grade 12. So for now, sit back. Please just make sure that you try and understand as much as you possibly can. And if you need to reach out to me, remember my email address. That's mlungisi.m.ngosi@gmail.com. That's MLUNGISI.M for Mary .nkosi@gmail.com. If you have any questions, please, you're more than welcome to send through those questions as we begin on Newton's laws. Let's go. Right, so the first thing that we're going to do, we're going to look at forces on an inclined plane. So suppose that we've got an inclined plane, something that looks like that, okay? And we know that it is obviously elevated at a particular angle, right? To call this an angle of elevation, right? Right, if we've got an object that we place on an inclined plane, there are several things that we know. Okay, so if we place that object, we know that it will tend to actually just roll down the incline, isn't it? Okay, so we want to know what are the forces that are actually acting on an inclined plane, right? So we say we elevate it at an angle theta, or as the Americans would say, theta, right? So let's say the mass of the object, or the mass of the trolley, is m, right? So if we had to draw a free body diagram showing or illustrating forces that are acting, all right, so what are the forces that would be acting? So first of all, we'd have the gravitational force, and remember that gravitational force is always acting vertically downwards, right? So what I'm going to do is, let me just draw a free body diagram there showing the forces that are acting on this particular trolley, right? In fact, you know what, let's just consider a friction to be there, right? So what are the forces that would be acting? Okay, so first of all, I know that if I just place it on the inclined plane, it would simply just tend to roll down, right? So we don't need to apply a force for it to do that. So if you think about it, as it rolls down, it starts moving faster and faster. So what does that mean? It means there must be a force that's actually pulling it down, right? So what are the forces that are acting on it? So now, first of all, let me just try and indicate my inclined plane there so that you can see. Right, so first of all, we've got gravitational force, which is acting vertically downwards. Okay, remember, this is vertically down. Okay, and we know that's the force of gravity. Okay, and then if we say it's a rough surface, right, so we know in this case we would have a frictional force. Remember, it would tend to roll down the incline, so as a result there would be friction there, right? So friction opposes the motion, so if it is moving, then it would be kinetic friction that we're talking about. And then also remember that the surface is already is exerting a force. So in this case, we know that we'd have a normal force. Remember, the normal force is at 90 degrees to our surface. So in this case, there is our normal force there. Now, please, I want you to note the following. Notice that this force, the force of gravity here vertically downwards, is not in a straight line with this normal force here. So if you remember what we've been doing, we've had forces, or we've had instances where we had forces that were acting, right, vertically, all right, okay, so vertically, and we had forces that were acting horizontally, isn't it? But this time around, because our plane is tilted, because we're on an inclined plane, we've got two types of forces. In fact, it's still the same thing. It's just that we've just tilted the plane a bit. So we've got two types of forces. We've got forces that are parallel to the incline, okay? In which case, when I look at this, the force that is parallel to the incline, that would be frictional force, right? And then we've got forces that are perpendicular to the incline. So if you think about a flat surface, so what you would have there would be a horizontal force that would be parallel, right? And it would be a vertical force that would be perpendicular. This time around, we've just tilted this, and then the force that is parallel, we've got forces that are parallel to the surface, and then we've got forces that are perpendicular. So the normal force would be perpendicular, all right? And then once again, just like we had in the previous case when we had forces that were acting at an angle, right? What we did was to try and resolve those forces, and that's exactly what we need to do here. So what I'm going to do is I'm going to just show you quickly how we can do that in terms of this force of gravity. Why? Because this force of gravity is kind of giving us a bit of a problem. And what is that problem? It's that it's neither parallel nor is it perpendicular, right? But what we want to do is to now resolve it into components that are both parallel and perpendicular. And how do we do so, right? So I'm just going to adapt this drawing just a little bit. So we can actually see that our incline is making an angle of theta there. As I said, you know, the Americans say theta. Okay, so there it is there. So now, if I now just draw two forces there, one in that direction, can you see that angle, that force there is actually perpendicular to my surface, isn't it? Right? So in actual fact, it's making a straight line. Okay. And then I also have another force. Now, I'm making this into a 90-degree triangle. All right. Where this side is 90 degrees. Okay. So now what do I have? Now remember, in fact, let me just write this down on this side here so that it doesn't confuse us. Can I write it on this side here? Okay, so this is our force of gravity here. This is the vertical force of gravity. So now what I've done is I have actually now broken down the force of gravity into those two components. The component which is perpendicular, right? So what I'll do is that I'll say this is Fg in the perpendicular direction, and then again a component which is parallel. Now this perpendicular component should be going perpendicularly downwards, right, in that direction, and then that parallel component is going in that direction parallel to the incline. Now if you notice, this line should be parallel to that line there. Okay, so hence we are saying it's parallel, right? And now I'm going to just resolve this. Now, ladies and gents, I can prove to you through geometry, okay, that actually this angle here, please, I just want you to remember this. If the angle here is theta, then the angle inside that triangle should also be theta. Okay, if you want me to prove that, I can prove that to you. Okay, but I didn't want to actually waste a lot of time on it. So if you think about that little triangle there, okay, if I take that as a triangle, so if I say that angle is 90 and that's theta, that would be 90 minus theta, isn't it? Right, but then I've got another right angle there. If this is 90 minus theta, right, and that whole thing is 90 degrees, so that should be theta. Okay, but I don't want to waste any further time on that. Just remember, when that angle there is theta, so that also becomes theta. Right, now look at this. So I've got the parallel component here of gravity, and I've got the perpendicular component of gravity. Right, now we need to express this because normally we would have been given the mass of the object, isn't it? So if we've got the mass, we can actually find the force of gravity, isn't it? So therefore, how do I now express the parallel component and the perpendicular component in terms of gravitational force? Now, if you look at this in the 90-degree triangle, this 90-degree triangle here, this side, we've got two sides. We've got the opposite side, right? So this is our opposite side. This is our adjacent side. So this would be our hypotenuse. So force of gravity would be the hypotenuse side, okay? Now, I want you to please note this. So now what I can simply do is say, well, if I wanted to find, let's start with the parallel component. So FG parallel. So this is opposite over hypotenuse, right? So this is the opposite side. This is the hypotenuse side. So it means that FG, or rather, let's rather say the sine of theta. The sine of theta will be equals to, right? That's opposite. What's my opposite side? That's FG parallel over, right, my hypotenuse. So that's opposite over hypotenuse, which is FG, right? Now, if I, okay, can I just remove this? So if I just cross multiply quickly, right? So this will give me, means FG parallel will be equals to FG, all right, force of gravity multiplied by the sine of theta. But you remember, how do you calculate FG? All right, the force of gravity or the weight. So it's mass times gravitational acceleration, right? So this would be mg, the sine of theta. Okay, right. So it means if I want to find the parallel component of gravity, I simply say it's mass times gravitational acceleration, the sine of theta. Right. Similarly, what do I also want to find? I also want to find the perpendicular component. Now, that perpendicular component, look at what it does. It now forms, in this case, it's on the adjacent side of our triangle, right? For those of you who are still struggling with that opposite and adjacent stuff, please refer to my previous video, and that should help you quite a lot in terms of trig ratios, right? So in this case, it's going to be FG perpendicular, right? That's the adjacent side over the hypotenuse. That's the cos of theta, isn't it? Right, so cos of theta would be equal to, now let's take our adjacent side, it's FG perpendicular divided by the hypotenuse in this case, which is going to be the force of gravity. Okay, right, now finally, we are simply going to do what we did previously, right? We did say that if you want to cross multiply, so FG perpendicular times 1, and that's FG perpendicular, and then that's going to be cos times FG, right? I'm just going to resolve it into, right, remember, so this is going to be mg, the cos of theta. Now, ladies and gents, if in the past few minutes that I've been explaining this, you're saying, but say I really don't understand what you've done, it's okay. What I just want you to get, please, right? Just remember the following. Remember this. Okay? Remember, if I want to get the parallel component of gravity, all I just simply do is going to be the mass times gravitational force, the sine of the angle, and the angle will be the angle of elevation there. Okay? If I want to find the perpendicular component, and by the way, we're going to need this, you'll see in just a little while. Nah? Okay, so if I want to find the perpendicular component of gravity, we're simply going to say it's mass times gravitational acceleration, the cos of the angle of elevation. Is that okay with everyone? Alrighty. Okay, let's get ahead. Right, so now at the end of the day, right, we have all of this now. So it means that when we've got a system that is on an inclined plane, now please, I don't want you to do this, okay? Right, please, when you draw the free body diagram, you either draw the free body diagram as it was initially. So you'll see if it was a drawing like this, or it was a scenario like this, you would actually be awarded 3 marks for it. So it means that they would be expecting for you to draw 3 forces, isn't it? Right. But if you wanted to draw the one that has the component, so you can either draw your free body diagram and express it like we did previously, right, where I had force of gravity, where I had frictional force, okay, acting in that direction. So there's a force of friction, okay, we said that's force of gravity, or for some of you who prefer to use weight, okay. And then we also had the normal force, and please remember that normal force is actually causing, or rather it's forming a 90-degree angle there, okay, with the actual surface, right? So this is the drawing that we had initially, isn't it? Right, but now versus which other kind of a drawing? So we had a drawing where we resolved this force of gravity into components, isn't it? So the alternative to drawing this, okay, which I somewhat prefer, right, because it actually helps me to clarify, or when I have to now calculate the forces, you'll see later on, right, when I have to do calculations. So we had frictional force, nothing changes about that. Remember, what did we want? We want to have forces such that we've got only forces that are parallel to the incline, and we've got forces that are perpendicular to the incline. Now, okay, so we've got normal force. We know that is going to be perpendicular to the incline. So, and please remember, I'm just drawing the very same drawing, but I'm just giving another scenario. Right. So instead of drawing that force of gravity there, instead I'm going to draw the components of it. Okay. Right. I hope you can you're able to follow. So in this case, what am I going to do? In fact, let me just draw them in another color so that you can see that clearly. Right. Instead, I'm going to draw the components. So which components did we have? We had that perpendicular component of gravity, right, which is Fg perpendicular, right? Remember that forms a straight line with that guy there, right? Should form, and it should also form, okay, so we've got Fg parallel there, right? And by the way, that Fg parallel value, right, please note we had it there initially, but we need to connect it to that dot, right? So as a result, we know that these are our forces. Please note once again, so what do we notice? We've got forces that are parallel to the incline, and we also have forces that are perpendicular to the incline. So we've kind of solved that issue that we had initially there. You remember, ne? Right. So in this case, every time that we've got forces on an inclined surface, right? So what do we know? We want to have only forces that are parallel. We want to have forces that are perpendicular. Okay. Now, why is it that we wanted that scenario? So if you look at the movement of this trolley, for instance, right, we know it's going to be moving parallel to the incline. So what are the contributing forces to the parallel motion? Of course, you can see it clearly now, right? It's going to be the force of gravity parallel. In fact, this is the force that is actually causing this guy to actually roll down, right? And then we've got frictional force that is opposing the motion, right? Of course, this time considering that the trolley is actually moving down the incline, isn't it? Right. So, and then we've got two forces that are perpendicular. All right. I hope you can already see this, right? That if you take, for instance, these two forces, of course, they are at equilibrium in the perpendicular direction. So what does that mean? It means when I look at this drawing, it means that my normal force, all right, and my gravitational force should be at equilibrium. So it means that their net force or their net result should be 0. And as a result, Okay, if you think about that, so it means that they should be equal, isn't it? Right. So in the event where we had to calculate friction, right, remember we always need normal force. So as a result, we know when we now need to calculate frictional force or kinetic friction, we're going to say coefficient of friction multiplied by normal force. But your normal force is no longer equal to, or in this case, just at equilibrium with the force of gravity. It is equal, or in this case, at equilibrium with the perpendicular component of gravity. All right, now, without wanting to complicate this any further, as I did say to you, ladies and gents, what is it that we've learned thus far? Please note these two formulas. When I want to find force of gravity perpendicular, all right, that's going to be mg, the cos of theta. When I want to find the parallel component, it's going to be mass times gravity, the sine of theta. All right, I hope that we are ready. I think what we're going to do is just dive into our first problem, all right, and then let's take it from there. Right, let's go ahead. So suppose we are given a 20 kilogram trolley that is being pulled up an incline, a 30-degree incline plane. Okay, and they tell us that it's accelerating up the incline at 1.5 meters per second squared. Okay, and the coefficient of friction, all right, is 0.3. And so what we want to find out there, so first of all, they ask us to draw a free body diagram, right? So what I'm simply going to do is, let's start with a free body diagram. So it means that when I look at the forces that are acting, right? Remember I said you must draw that dot to be big enough so that you know if there's more than one force acting in the same direction, right? You can be able to accommodate that. Right, so what are the forces? So it's going to be the force F. So I'm going to say this is force applied. So this is the applied force. So this is our applied force there, right? And then what do we have? We know we're going to have the normal force that is going to be at 90 degrees. So that's our normal force there. You can say F normal, right? And then we also have gravitational force that's acting vertically downwards, but we also have friction. Okay, so let me just put it there. Friction always opposes motion, right? So you can say frictional force there. All right, so now then you've got force of gravity. So this is the first kind that we're going to draw. So we've got force of gravity that is acting vertically downwards. So normally this would be a 4-mark question. Okay. Look, I haven't been consistent here. So this is F applied, F applied force of gravity. Let's say F normal, and then F friction. Okay. Right, sorry about that. Okay, but in this kind of a force, but remember in this kind of diagram, remember I don't have my parallel and perpendicular components, isn't it? So as I said, you can draw this drawing, it's 4 marks, nothing wrong with it, right? But I would prefer to actually have the other kind of a drawing, right? So I'm going to draw that one very quickly, right? So what are the forces that we have? We've got a normal force there, we've got force applied. So in these ones I'm just going to abbreviate. So that's normal force, that's force applied, that's frictional force. Okay, so that's kinetic friction. But instead of having that gravitational force, what am I going to have instead? You're quite right, we're going to have our components, isn't it? So I'm going to instead have FG perpendicular. Note now, this guy makes a straight line with that one there. So that's going to be my FG, my perpendicular component. And by the way, some of you prefer to call this FGY, and FGX. There's nothing wrong with that. Okay, right, you can do so. All right, and then I've got my FG perpendicular, my parallel component rather of gravity. So remember, it's acting down the incline, right? So FG parallel. Okay, right. So in this case, those are my two forces that are actually the equivalent of that force of gravity. So I've kind of replaced that one force with those two. Remember, these two acting together are exactly are the vector equivalent rather of that force of gravity. Okay, right. So what I'm going to do for myself, please allow me to do this. So I'm just going to quickly just calculate those forces. So FG parallel, remember we said this is mg, the sine of theta. So our mass is 20 times 9.8. Okay, all right, I'm just going to move this a little bit. Okay, so the sine of 30 degrees. Okay, and let's see, so that's going to be 196. Okay, so 6 times, all right, so we get 98 newtons. Okay, and I'm going to calculate FG perpendicular. Remember we said that's mg, the cos of theta, isn't it? Okay, so that's my perpendicular component. That is going to be the cos of theta. So in this case, I'm simply going to say this is 20 times 9.8. Okay, the cos of 30 degrees. Remember, angle of elevation is 30 degrees. So that's 20 times 9.8. Okay, let me just put my calculator there. Okay, so that's 20 times 9.8. The cos of 30. Okay, right, I get 0.74 newtons. Okay, if you so prefer, you can actually calculate within the equation when you've just generated the equations. Now in this case, what do we want to do? Now we want to calculate, right? Let's begin to answer the questions. Right, now they wanted to find out what is the value of the frictional force. Now, ladies and gents, I want you to please pay careful attention. So in answering question 2.1, this is what I'm going to do. Very simple, right? I'm going to say, well, in this case, I know that F net is equals to MA, but which forces am I taking? I'm taking the sum of forces in the vertical. Why am I looking for those forces? Because in order for me to calculate friction, I need the normal force. And the normal force is part of the forces that are perpendicular to the incline. So I'm going to take the sum of forces in the perpendicular direction, or in the y dimension, some of you would prefer. Right, and remember, this thing is at equilibrium. It's not moving in the perpendicular. So in this case, this is going to be 0. So as a result, what do I know? It means that my normal force minus FG perpendicular is equals to 0. And I'm just dragging this so that you can see it. Okay, sorry. So normal force would be equal to our FG perpendicular value. All right, and we've already calculated that, isn't it? Okay, so that would be 169.74. Okay, so that's 169.74 newtons. Okay, right. Now, ladies and gents, what did we want to do? We wanted to calculate the value of friction, isn't it? Okay, so I'm just going to move this upwards a little bit. Okay, so we wanted to find out what the value of friction is. So how do we get the value of frictional force? Now, the only reason I did all of that is so that you can see where I actually sourced that from. So if you understand it, you can just simply go from with this step and then just substitute that there. Right, so what is our coefficient of friction? We're given the coefficient to be 0.3. So 0.3 multiplied by that force there, that's 169.74. Okay, fortunately I still have that in my calculator. times 0.3, okay, and we get a value of 50.92 newtons. Okay, so I've got my frictional force value, right? And now what do I want? I want to calculate. So I want to go to the next question and now say, sorry, that's 2.2. Okay, they asked us to calculate the value of force F. Okay, so we want to get that force F value, right? So we're going to say, all right, because we already have, or rather, let's apply Newton's second law, F net is equals to ma. But which forces are we taking? Remember, we said this thing is acting parallel to the incline. It's moving up the incline, isn't it? So it's moving up there. So as a result, I'm going to take the sum of forces that are parallel to the incline, and this is equal to ma. Now, the sum of forces that are parallel, this is going to be force applied. Okay, so this is going to be force applied. Look at this. I'm going to take direction of motion upwards as positive, right? Up the incline as positive. So it's my force applied minus the frictional force, okay, minus the force of gravity parallel. And this is equal to ma. Okay, right. I'll just take it up a little bit so that you can see it better, right? So F net, that's force applied minus frictional force minus Fg parallel, and this is equal to ma. Now, ladies and gents, okay, you know how the cookie crumbles. So our force applied was the force F, right? But we do have the friction. We just calculated it there. So minus 50.92 minus the force of gravity, okay? The parallel component of gravity, you remember it? We calculated it there. We said it was 98 newtons. Okay, the mass is 20, but we also knew what the value of acceleration is. They told us that it's accelerating at 1.5 meters per second squared. And by the way, we took up the incline as positive, so that should be up a positive 1.5 there. Okay, all that's left, ladies and gents, is just to do our mathematical gymnastics. Okay, so I'm going to say 20. Okay, let's say 20 times 1.5. 1.5. Okay, and I'm going to add 98. Okay, because I'm taking it to the other side, and I'm going to also add 50.22. Okay, right, so there's F there, which is equal to 178.22 newtons. Okay, so it means the value of force F is 178.22. All right, I hope that that has been helpful. Right, let's take another exercise. So I hope this one has been somewhat well understood. Okay, so let's take the next one. Right, let's take our second scenario. Okay, so we're looking at a trolley that is freewheeling, okay, down an inclined plane at a constant speed of 5 meters per second, right? So we want to find out, so first of all, we need to draw a free body diagram, right? So we're going to start with that just now. Okay, so what are the forces that are acting on the trolley? So now, once again, we know that we've got the normal force. So I'm sure you've already got that figured out by now, right? That so suppose this is our incline. So we know that we're going to have the normal force acting perpendicular to that incline there. So there's our normal force there. You've got your gravitational force that acts vertically downwards, force of gravity. Now please, I want you to note there is no applied force. They said it is freewheeling, so meaning it's moving essentially on its own, right? So but they did to some extent. We know that there should be frictional force. And how would we know that? I mean, if it's moving at constant speed as opposed to it accelerating downwards, it does mean that there must be a force that's opposing, isn't it? Right. So of course, if I had all the time in the world, I'd be as elaborate as possible in this question, but I just want you to get the gist of it. So we know that's our kinetic friction there. Okay, so there it is. But remember, ladies and gents, what did we say? We said all that I can simply do is just redraw this diagram such that I will now be able to include okay, let me just draw my, so again it's going to be my normal force. Okay, so either one of the two, right? So my frictional force, but instead of having force of gravity, okay, what am I going to do? You are right. We are going to actually break that down into components, isn't it? So that's going to be force of gravity parallel. Okay, right? So remember, force gravity, the parallel component of gravity is always acting down the incline, isn't it? Okay, so in this case, it's acting in that direction. Okay, and we've got the perpendicular component of gravity. So there it is there. So we've replaced that force with its components, which would have been here and there. Okay, but remember, we don't draw that those components when you've drawn the force of gravity, right? So you either have this type of drawing or that type of drawing. Okay, right. Now, ladies and gents, please, I want you to note. So in this case, I want us to answer the second question. So obviously, this would be a 3-mark question. We always consider these to be basically just one and the same thing as this one. Right, so now they want to find the coefficient of friction. Okay, so now in answering that question, I'm simply going to say, let me take the black marker. Right, so I'm going to simply say, right now we're answering the second question. Right, coefficient of friction. So I know that frictional force would be equal to coefficient multiplied by the normal force. Now, ladies and gents, let's try and find those two components of ours first. So I know FG parallel. We said this is mg, the sine of theta. So I'm going to just write it there, the sine of theta. Okay, so this is going to be 10 times 9.8, the sine of 20. Okay, so okay, let's take that quickly. So that's 10 times 9.8, the sine of 20, and I get 33.52 newtons. That's my force of gravity parallel, right? And then what about my perpendicular component? This is simply going to be mg, the cos of theta. Okay, right? So now I'm going to have 10 times 9.8, the cos of 20 degrees. So okay, let me just replace that with a cos. So that's 10 times 9.8, the cos of 20 degrees, and I get 92.0, I'll just say 09. Okay, 92.09 newtons. Now notice, what am I trying to find here? I'm trying to find the coefficient of friction. Notice, okay, I don't know what the coefficient of friction is, but I'm looking for but I do have the normal force. Now, how would I have the normal force? Remember that the normal force is equal to our FG perpendicular. You saw that in our previous example, isn't it? Right, so in this case, our normal force would be equal to are FG perpendicular because both of those are acting in the perpendicular dimension and they are at equilibrium. It's not moving in that direction. So in this case, it means that this value here would be 92.09. Now, do you agree, ladies and gents, that we've got two things that are unknown to us here? We don't know what frictional force is, but we don't know what coefficient is. We're looking for the coefficient of friction, right? So what I'm going to do is, let me leave this as my equation 1, okay? So how am I going to get now the frictional force? Remember that friction is acting in the parallel dimension. So I'm going to say, okay, so now let's take the sum of forces. So F net is equals to MA, right? So let me take sum of forces in the parallel dimension, and what is it equal to? Remember, they said to us it is moving at a constant speed. Ladies and gents, please, and I want you to remember this. As soon as they say something is moving at a constant speed, remember that it doesn't matter even if the value is given, the value of the speed is given, but when it comes to Newton's laws, as soon as they say constant speed, that simply tells us that acceleration is equals to 0 meters per second squared. Now, someone asked me, what happens when they say to me constant acceleration? Well, that changes nothing. It means that they've just given you the acceleration. Remember that we always assume a constant acceleration anyway, okay? So in this case, we know that F net is equals to MA, sum of forces in the parallel, that's equal to MA, but our acceleration value, that is going to be equal to 0. So it's going to make this whole thing on the right hand side to be equal to 0. Now, obviously it's going down the incline this time. So I'm going to take sum of forces, or rather the direction downwards as positive. So what are my forces? It's going to be FG parallel minus the frictional force, and this is equal to MA, right? And what is my FG parallel value? You remember, we said it was 33.52. So that's 33.52 minus the frictional force, and this is equal to, remember we said this is 0. So it means our friction value, right? So our friction value is 33.52. If we take that to the other side, we're going to have a value of 33.52. So now we've got the frictional force, okay? So we can now go back to that first equation. We can substitute into that first equation. So now we can simply go back and say, well, our frictional force is 33.52, which is equal to the coefficient multiplied by 92.09, okay? And then taking our calculator there, okay, sorry about that. Okay, so we're going to basically divide both sides by 92.09, 92.09, and our coefficient value, that's 33.52 divided by 92.09, okay, and we get a value, I seem to get a coefficient value of 0.36. So my coefficient there is 0.36. Okay, I'm just going to round it off into 2 decimal places. Okay, right. So I hope that was interesting enough. So all I'm simply saying, ladies and gents, when we've got a force, when we've got forces on an incline, what we're simply going to do, just break those down into their respective components, and then we just deal with them as we should. Now, what I simply want to do quickly is just take a past exam question, right? And then I think that will be kind of the last example that I do with you, okay, just to show you how to apply this, whether in an exam situation, okay, so so that you know that, I mean, you can actually answer this with ease, okay, right. All right, so we take this from past exam question. They say block of mass 1 kilogram is connected to another block of mass which is 4 kilograms by light inextensible string. You remember that light inextensible just simply tells us that it's not an elastic string. All right, so it means that the acceleration on the one should be the same as the other. Right, so the system is pulled up a rough, okay, so we know that there's friction here, horizontal, a rough plane inclined at 30 degrees to the horizontal by means of a constant force of 40 newtons, okay, so 40 newtons, force that's parallel to the plane as shown in the diagram. So there's our 40 Newton force there that's acting, okay. Right, now they say to us the magnitude of the kinetic frictional force between the surface and the 4 kg. So we know we are given the frictional force for the 4 kg block, right? Okay, they said it's 10 newtons. And then they say the coefficient of kinetic friction for the 1 kg block. So here they give us the coefficient of friction, right? Between the 1 kg block and the surface is 0.29. Okay, and then obviously, ladies and gents, they tell us to state Newton's third law in words, right? Please remind yourself, okay, if body A exerts a force on body B, then body B will exert an equal but opposite force on body A, right? Of course, there are some other ways of expressing the same law. Okay, you can just state it as it is comfortable. Just make sure that you get it right. That's the main thing. Right, now they say draw a labeled free body diagram showing all forces acting on 1 kg block as it moves up the incline. You know what? I'm just going to simply just go for it. Okay, for the one that I prefer. Right, so it's going to be, let's say there's my free body. Ooh, what a big dot. Okay, so I'm going to have, I know there's force applied there, so I'm applying a force upwards. Okay, so it's parallel to the incline, so that's going to be force applied. Okay, I'm going to have my normal force. Okay, so there's my normal force there. Okay, I'm going to have gravitational force acting downwards, but you know what, I'd rather draw the components of it. Okay, so let's have force of gravity perpendicular, so so that's Fg, our perpendicular component. So I'm going to have force of gravity parallel, okay, as well as, now do you agree with me, we still have that tension there between the two, right? So there's tension between the two, okay, so there's tension between the two surfaces, between the two trolleys or two boxes or whatever, blocks. All right, so also we have the frictional force. I can hear some of you already complaining, so many forces in the same direction. Yeah, that's how the cookie crumbles, ladies and gents. Right, so we've got three forces that are actually opposing that motion there. We've got Fg parallel, we've got tension, we've got frictional force, right? So remember, some of you would have preferred not to include these two, but rather have gravitational force acting vertically downwards. Nothing wrong with that, but I'm going to stick with this one. Okay, right. So, and by the way, you see, they were giving us 5 marks for it. Okay, so you can count those force. So force applied, normal force. Remember, we take these as 1, so that's 3, that's 4, and that's 5. Okay, right. So now the third question, in a sense, they say to us calculate the magnitude. So they want to find out the magnitude of the kinetic frictional force between the 1 kg block and the surface, right? So in this case, we know, okay, I'm going to just simply say my frictional force value is going to be coefficient multiplied by the normal force, right? They gave us the coefficient as 0.29. Okay, remember we're given there. They told us it's 0.29, and then multiplied by the normal force. But you remember now, the normal force is equal to our perpendicular component. And how do we get our perpendicular component? We said it's mg, the cos of theta, right? So this is going to be the mass, so that's 1 times 9.8 multiplied by the cos of the angle, and our angle of elevation, all right, please note it there, that's 30 degrees, right? So it's 30. Okay, I know you already have your calculators out, so that's 0.29 times 9.8 cos 30. Okay, and that gives me a frictional force value of 2.46 newtons. Okay, so keep in mind that normal force is equal to the perpendicular component of gravity, and we said when we calculate it, we just simply say mg, the cos of the angle, and the angle of elevation is 30. Right, next question. Okay, they say now calculate the tension in the string connecting the two blocks. All right, so it's going to be quite a bit of work, but we are equal to the task, right? So now look at this. What are we going to have? Okay, so now this was 4.3.1. Okay, this is 4.3.2. All right, now let's start with the 1 kg block. So I'm going to say for the 1 kg block, now please remember, ladies and gents, okay, please keep in mind that when I consider this this calculation, now because this thing is actually moving in the parallel dimension, I'm gonna take my net force. All right, we know F net is equals to MA, but what forces am I now going to consider? Okay, the sum of forces in which dimension? In the parallel dimension, right, is equal to MA. Alrighty. Okay, now I'm going to now find out, okay, first of all, what are the forces? I'm going to assume it's going up the incline. Okay, they did say it is being pulled up, right? So it means I'm going to have force applied minus the frictional force Fk minus the tension minus Fg parallel. Okay, right, which is equal to MA. Now please remember, okay, we are still just working on the 1 kg block. So force applied, they told us it's 40 newtons minus frictional force. Remember, for the 1 kg block, we said it's 2.46 minus the tension. We don't know what the tension is. That's what we're asked to get. Minus Fg parallel. And remember that parallel component, we said this is equal to mg, the sine of theta. So this is 1 times 9.8 sine of 30. Okay, this is equal to 1 times a. We don't know what acceleration is, right? So 1 times a, mass times acceleration. Okay, let's try and simplify that whole thing. I've got 40 minus 2.46 minus 9.8 sine of 30, okay, which is 4.9. Okay, so that gives us, get a value of 32.64. So all of these give me 32.64. Remember, we still have minus t there. right? And this is equal to the value of A, right? 1A. So that's going to be my equation 1. If you don't mind, I'm just going to carry this over here. Okay, right. So I'm going to say, right, now let's take for the 4 kg block. Okay, remember, what are the forces that are acting? It's going to be the tension that's pulling it up there, right? So for the 4 kg block, we have tension that's pulling it up. We've got the normal force. So this is T, that's normal force. That's FG perpendicular. That's going to be friction. Okay, right. So in that case, we've got friction, FK, and then we also have FG parallel. It's opposing the motion. Remember, FG parallel is always acting down that incline, isn't it? Okay, right. So in this case, for the 4 kg, we know that F net, so we're going to take the sum of forces in the parallel dimension is equal to MA once again, right? So what are the forces? It's going to be tension minus FG parallel. Remember, now we are dealing with the parallel for the 4 kg. If you wanted to, you can just put some labels to it, okay? FG parallel minus friction, and this is equal to MA. Okay, let's say tension minus, what's our parallel component? That's 4 times 9.8, the sine of 30. Okay, right, minus our frictional force. Remember, for the 4 kg block, they had told you that the friction is 10 newtons. You remember, right? So that's minus 10 newtons, and this is equal to 4A. Sorry, I'm just gonna have to squeeze it there, right? So that's T. Okay, so that's 4 times 9.8. 4 times 9.8 sine 30. Okay, and minus 10. Okay, so I end up with T minus 9.6 is equals to 4A. Now this would be my equation 2, isn't it? Okay, right. If you want to, we are looking for the value of T. We already know that A is equals to that value, so we can substitute for that acceleration in equation 2. So you can just simply say substitute equation 1 into equation 2. Okay, so I've got T minus 9.6 is equal to 4 into, now A is 32.64, okay, minus T. Okay, let's try and solve for that. So we've got T minus 9.6, which is equals to 4 times 32.62. So that's 4 times 32.62. Sorry, 36.64 rather. I get 130.56 minus, remember it's 4 into this and 4 into T, so minus 4T. Okay, right. So let's group all our like terms. So we've got 4T this side, we take it to the other side, it becomes positive. So T plus 4T will give me 5T. And then if I take this to the other side, it also becomes positive. So I've got 130.56 plus 9.6. Okay, I think I end up with 130.56 131, sorry, 139, no, 140, okay, 0.16. All right, so that's 6 plus 5, yeah, plus. So yeah, and then we divide both sides by 5. Please, you can verify that for me, ladies and gents. So that's 130.56 plus 9.6. Yeah, so we divide that by 5 and we get a value. T is 28.03. Okay, you can say 0.32 if you want to be pedantic about it, right? So we get a value T is equals to 28.032. So essentially, yeah, that's how the cookie crumbles. When you've got forces that are on an inclined plane, remember, you break that force of gravity down into its components, and as a result, you are going to now use that, by the way, to get the parallel component and the perpendicular component. In which case, we said parallel, remember, it's always going to be mg, the sine of theta, angle of elevation, and then perpendicular, that's mg, the cos of theta. Look, we're going to still have some more examples on this when we do revision. Please make sure that you subscribe, and you know, remember, just tell others, man. Of course, the point of this is that everyone should benefit. I want even those who are still coming, who are still going to do matric, to actually benefit from this. So at the end of the day, remember that physics is not difficult at all. We just need to find a way to approach it in a way that will be practical for all of us, right? Otherwise, I'm going to leave it here. If you've got any questions, as I did say, you can hit me up on my email. That's mlungisi.m.nkosi@gmail.com. Don't forget to subscribe. Thank you, and I'll see you on another installment where we'll be doing some more of physics. Sharp, sharp.